This is SpaceTime Series 23, Episode 77. Coming up on SpaceTime. Stunning first images of the Sun sent back by Solar Orbiter. More evidence that Venus is volcanically active. And all systems go for NASA's Mars Perseverance rover mission and the first flight of a helicopter on another world. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The European Space Agency Solar Orbiter has sent back its first stunning close-up images of the Sun, revealing miniature omnipresent solar flares, which scientists have named campfires. The observations, which are part of the spacecraft's early technical verification commissioning phase, are providing scientists with a hint of greater science to come, as the enormous potential of Solar Orbiter reaches fruition in coming years. ESA Solar Orbiter project scientist Daniel Mueller says these first images are already providing scientists with some interesting new phenomena. The data is allowing mission scientists to see how the probe's 10 scientific instruments are complementing each other, providing astronomers with a holistic picture of the Sun and its surrounding environment. Launched back on February the 10th, 2020, Solar Orbiter carries 6 remote sensing instruments or telescopes that image the Sun and its surroundings, and 4 in situ instruments that monitor the environment around the spacecraft itself. By comparing the data from both sets of instruments, scientists are getting insights into the generation of the solar wind, the stream of charged particles from the Sun that influences the entire solar system. The unique aspect of the Solar Orbiter mission is that no other spacecraft's been able to take images of the Sun's surface from a closer distance. Those miniature solar flares, they're calling campfires, shown in those first images, were captured by an instrument called the Extreme Ultraviolet Imager from Solar Orbiter's first perihelion, the closest point in its elliptical orbit to the Sun. At the time, the spacecraft was only 77 million kilometres from the Sun's visible surface. That's about half the distance between the Earth and the Sun. Campfires appear to be smaller relatives of the solar flares we observe from Earth, only a million or billion times smaller. The Extreme Ultraviolet Imager takes high-resolution images of the lower layers of the Sun's atmosphere, the solar corona. The Sun may well look quiet at first glance, but when examined in detail thanks to Solar Orbiter, scientists are seeing these miniature flares everywhere they look. Researchers are still trying to determine whether these campfires are just tiny versions of big solar flares or whether they're produced by an entirely different, as yet unknown process. Some scientists are already speculating they could be contributing to solar heating, one of the most mysterious phenomena associated with the Sun. The solar corona is the outermost layer of the Sun's atmosphere that extends millions of kilometres into outer space. The corona is a temperature of more than 1 million degrees Celsius, which is orders of magnitude hotter than the 6,000 degree surface temperature of the Sun. But mystery still surrounds why temperature should increase with distance from the solar surface. It's counterintuitive and not well understood. After all, things are supposed to get cooler the further away you get from a heat source. Meanwhile, another instrument aboard Solar Orbiter, the Polarimetric and Helioseismic Imager, is taking high-resolution measurements of the magnetic field lines on the surface of the Sun. It's designed to monitor active regions on the Sun, areas with especially strong magnetic fields that can give birth to solar flares. During solar flares, the Sun releases bursts of energetic particles that enhance the solar wind that's constantly emanating from the Sun into the surrounding space. When these particles interact with the Earth's magnetosphere, they cause spectacular auroral displays. But they also cause dangerous geomagnetic storms known as space weather, which can destroy spacecraft, disrupt navigation and telecommunication systems, black out power grids on the ground, cause the orbits of spacecraft to decay, and dangerously increase radiation doses for astronauts in space. Right now, our Sun is at a quiet phase in its 11 Earth-year solar cycle. But because Solar Orbiter is at a different angle to the Sun from that of the Earth, scientists can see an active region that isn't observable from Earth. It's the first time they've been able to measure the magnetic field at the back of the Sun. The data is showing that the strength of the solar magnetic field varies across the Sun's surface. The 4 in situ instruments on Solar Orbiter characterize the magnetic field lines and the solar wind as it passes the spacecraft. This allows scientists to estimate where on the Sun a specific part of the solar wind is being emitted. They can then utilise the full instrument set of the mission to reveal and understand the physical processes operating in the different regions of the Sun which lead to the solar wind's formation. And of course, this first data is just the beginning. Solar Orbiter will get much closer to the Sun over the next 2 years, eventually coming to within 42 million kilometres of the Sun's apparent surface. This report from ESA TV.
Solar Orbiter came within 77 million kilometres. Never before has a camera been this close to the Sun.
Solar Orbiter's first close approach to the Sun has enabled us to, for the first time, operate all 10 instruments on board together. Initially, they had been checked out one by one, like tuning individual musical instruments, and now it was time for them to perform together for the first time.
Solar Orbiter was launched on the 10th of February this year, but the process of checking out the 10 instruments and a total of 27 telescopes and sensors on board has been hampered by the COVID-19 pandemic. For the first time, spacecraft commissioning was carried out from people's homes, an effort that's paid off.
Receiving this first science data was really exciting. We see already little features we haven't seen before, like little flashes of light that look a little bit like solar flares, but are much, much smaller than the solar flares we used to know.
The scientists refer to these flashes as campfires. They could be part of the process that heats the outer layer of the Sun's atmosphere, the corona. And although the mission's at an early stage and the instruments aren't fully calibrated, these results provide a tantalising glimpse of the discoveries to come.
This first data allows us to tune the software on board, to calibrate the images even better, so that we can get ready for the real science phase and for even closer approaches to the Sun.
Solar Orbiter has a long journey ahead of it. During this cruise phase of the mission, the spacecraft will study the solar wind, the stream of charged particles the Sun emits, producing more useful science.
Having been involved in Solar Orbiter for over 13 years, it's been an amazing moment to see the first data and images, because this is something that I had been waiting for as a scientist for many years. And following this entire process, from conceiving the spacecraft, building it, launching it, and then see it actually work in orbit is fantastic.
And this is only the beginning. Just a few months after launch, Solar Orbiter is already giving us a new understanding of our neighbourhood star and its influence on the Earth.
And that report from ESA TV featured ESA Solar Orbiter project scientist Daniel Mueller and ESA's instrument operations scientist Anik de Groof. This is SpaceTime. Still to come, all systems go for a mission that will hopefully provide the first helicopter flight on another planet. And later in the science report, a new COVID-19 vaccine being developed at Oxford University showing early positive signs of immune responses. All that and more still to come on SpaceTime. There's growing evidence that Venus may still be volcanically active. A new study has identified 37 recently active volcanic structures on Venus. The findings, reported in the journal Nature Geoscience, provide some of the best evidence yet that Venus is still geologically active. Scientists have known for some time that Venus has a younger surface than planets like Mars and Mercury. That means there's something going on that's renewing Venus's surface. On Earth, that's caused by tectonic plate movements and erosion. Evidence of a warm interior and geologic activity dot the surface of Venus in the form of strange ring-like structures which scientists call coronae. Coronae form when plumes of hot material deep inside the planet rise through the mantle layer and crust, sort of analogous to the deep mantle plumes on Earth which have created the Hawaiian Islands chain and Iceland. The thing is, it was thought that the coronae activity on Venus were probably signs of ancient activity, and that Venus had cooled enough to slow geological activity in the planet's interior and harden the crust sufficiently so that any warm material from deep inside wouldn't be able to punch through. But the exact processes through which mantle plumes formed coronae on Venus and the reasons for variation among these coronae remain issues of debate. So, In order to try and resolve the issue, the authors used numerical models of thermomechanical activity beneath the surface of Venus to create high-resolution three-dimensional simulations of coronic formation, resulting in the most detailed view of the process ever undertaken. The simulations allowed the team to identify several different stages in corona evolution. It allowed them to identify the sorts of geological features which would only be present in either current or very recently active coronae. And they were then able to match these features in the simulations to actual geological features observed in coronae on the surface of Venus. The observations have identified coronae in different stages of development, and that suggests a continuing ongoing evolution. In other words, the interior of the planet is still churning. In fact, the authors were able to identify at least 37 coronae that were active very recently. One of the study's authors, Lauren Montesi from the University of Maryland, says the new data represents the first time that scientists have been able to pinpoint a specific structure and say this is not an ancient volcano, but one that's active today. Perhaps dormant, but definitely not dead. The active coronae on Venus seem to be clustered in a handful of locations. That suggests areas where the planet's most active, and that in turn provides clues to the working of the planet's interior. These results may help identify target areas where geologic instruments should be placed on future missions to Venus, missions such as Europa's Envision, which is slated for launch in 2032. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
The volcanoes, or some of the volcanoes on Venus, might still have a little bit of pep in them. Is that the case?
Indeed, that's right. So this is quite exciting research. It's very good that we're seeing this sort of thing being published, in advance of possible upcoming Venus missions, because it sets the scene in a way. It sets the scene as to the questions that we might ask on a future Venus mission. So what this is about is essentially a reanalysis, Andrew, of some of the radar imagery that came back from Venus back in the 1990s, actually. This is from the Magellan spacecraft. Magellan was equipped with radar and basically mapped the surface of Venus for the first time because, of course, Venus has this thick, poisonous atmosphere that we can't penetrate, at least under normal circumstances. Certainly with visible light, you do get nearer the bottom with infrared, but even then it's not giving us any idea of what the surface is like. Radar is the only way to do it. So a group of scientists in the United States have trawled through the Magellan data, and what they're looking for specifically is some features which they're ring-like structures on the surface of Venus. They're called coronae, and coronae being the plural of corona, which of course means crown. And these days our minds immediately leap to the coronavirus when we think of that word, but this is nothing to do with virus. This is just the shape of these structures. They're crown-like structures. There's some understanding already of how these things are formed because they're thought to be caused by hotspots underneath the surface of Venus, upwelling of hot rock there. We've got these hotspots underneath the surface of Venus, and so you get upwelling and penetrating through the crust and giving you a volcano. Now, we know that Venus does not have plate tectonics, and that means that a bit like the phenomenon on Mars, where you've got these huge volcanoes penetrated through the crust and just kept on going through the same hole in the crust because nothing's moving. There's no plate tectonics. So you get very large volcanoes. Now, I think that is also true on Venus, except that Venus is far more volcanically active than Mars ever was. It has the most number of volcanoes of any body in the solar system. So what they've done is they've looked at these corona structures. In fact, I think 133 of them have been examined in detail, and essentially details of the shape of these. And I should explain that it's kind of almost like a ring formed with a trench-like structure around this volcanic plateau. Some of them are thousands of kilometers across. The bigger one, they're typically 100 kilometers or so. But they also have these sort of radial fault lines in them as well. So there are faults occurring too. And it's by looking at those structures that you can get an idea as to how long ago the activity ceased. Basically, one of the authors of this work, somebody called Anna Gülke, has said, our work shows that some of the interior heat is still able to reach the surface even today. Venus is clearly not so geologically dead or dormant as previously thought. The evidence seems to be that of the 133 coronae that have been investigated, 37 seem to have been active. And this is the bottom line, within the last 2 to 3 million years. And of course, that's very much the recent past in geological terms. It probably speaks volumes for the idea that Venus actually is volcanically active today. And what a thing, that you can now sort of imagine beneath those layers of clouds.
Fantastic that we can reanalyze data from old missions and extrapolate more information from it, because we've got the tools now that we may not have had 30 years ago or whatever, we can reanalyze data from these old missions and get even more value out of them. I think that is just an amazing step forward for astronomy as well.
Yeah, that's right. With modern tools, modern software, the kind of analysis tools that we have these days, which certainly weren't around in the 1990s. So really extraordinary stuff, Andrew. And I think really interesting news as well, that we have yet one more volcanically active body in the solar system, along with the Earth and Jupiter's moon Io.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. Of course, as well as being Earth's nearest planetary neighbour, Venus has often been considered to be Earth's sister planet. That's because they're both almost the same size and with a similar mass and diameter. And importantly, they were both formed in the same part of the solar system, under similar conditions, and out of the same materials. However, if Venus really is Earth's sister planet, then it's somewhat of a twisted sister, with a mad runaway greenhouse effect. It's all kind of funny, really, because Venus once stirred speculation that it could host the first human colony in space. Forget Mars. Years ago, Venus was seen as the place to go. See, scientists thought Venus's dense cloud cover meant lots of rain. After all, it's closer to the sun than the Earth, so the temperatures are hotter, and that would mean more water evaporation and consequently more rain clouds. It all sort of seemed to make sense. And then imagination took over. Under that thick cloud cover, Earth's sister planet would have been covered in a lush green tropical rainforest. Think Amazon jungle on steroids. And from the idea of some primordial jungle environment, it's only a short hop, skip and jump, at least for the imaginative, to somehow having a planet full of dinosaurs. Now, it might have been a long bow to draw, but there were those who drew it. Of course, we now know, thanks to Soviet and American probes, that Venus in reality is probably the closest thing to hell in our solar system. Its surface, thanks to its runaway greenhouse effect, is scorchingly hot, with average temperatures of around 462 degrees Celsius. That's hot enough to melt lead. And as for those thick, opaque, planet-shrouding clouds, well, they do cause rain, but the rain isn't water. Instead, it's droplets of metal-eating sulfuric acid. And it gets even better. Scientists have seen what look like snowcaps on some of Venus's tall mountain ranges. But here again, that snow isn't frozen water. It's actually metallic. Venus's thick chemical soup clouds are so heavy, they're crushing the planet's rich carbon dioxide-based atmosphere, acting like the lid of a pressure cooker, and giving the planet a surface pressure some 92 times greater than the average sea level surface pressure on Earth. As we mentioned at the top of the story, Venus is dominated by volcanoes. Well over 600 volcanic structures have been counted so far. That's more than any other planet in the solar system, including the Earth. In fact, Venus's surface is 90% basalt and consists of a mosaic of volcanic laval plains, showing evidence of regular periodic resurfacing by floods of lava. And this all indicates that volcanism is playing a major role in reshaping the planet's surface. In fact, Venus may have had a major global resurfacing event around 500 million years ago, based on the low density of impact craters on its surface. Radar soundings from NASA's Magellan probe have revealed evidence for comparatively recent volcanic activity at Venus's highest volcanic peak, Mount Mons. This comes in the form of ash flows near the summit and on the northern flank. Now, although many lines of evidence suggest that Venus is likely to be volcanically active, present-day eruptions at Mat Mons are yet to be confirmed. The radar images we get of the Venusian surface show lots of shield volcanoes, widespread lava flows, unusual volcanoes called pancake domes, and weird arachnoid or tick-like structures called scallop margin domes, which are completely unlike anything found on Earth. Interestingly, there's no evidence of any sort of plate tectonic activity on Venus. Venus orbits the Sun every 224.7 Earth days, and it rotates in retrograde compared to most of the other planets in the solar system. In other words, the Sun rises in the west and sets in the east. And that rotational rate is extremely slow. In fact, a day on Venus lasts 243 Earth days, meaning a Venusian day actually lasts longer than a Venusian year. Just getting to the surface of Venus is a big job. In fact, the Russians have sent numerous spacecraft to the surface, but they've all had a really tough time surviving. The first few were crushed and cooked in the Venusian atmosphere long before reaching the ground. Now, eventually, the Russians built a probe that was strong enough to make it all the way down to the surface intact. But it wasn't able to send back much data, because its equipment, including the camera lens cap, had melted by the time it had touched down. Eventually, one Russian probe did make it all the way down to the surface, surviving long enough to send back a few seconds of precious data and images. What scientists saw was the most alien environment they've ever witnessed, a world bathed in a half-yellow light by the thick cloud cover. The surface is covered in jagged slabs of maroon-coloured rocks, slowly being baked over the eons to create a desertscape periodically resurfaced by volcanism. Now, based on the Russian experience, the Americans and Europeans have limited their explorations of Venus to orbital missions. In fact, the extreme adverse conditions of Venus for human life have caused the focus of planetary missions to shift very much towards Mars, which is further away, but somewhat cooler. And that's probably why there are 3 missions going there at the moment. This is SpaceTime. Still to come, it's all systems go for the first helicopter flight destined for another world. All that and more coming up on SpaceTime. When NASA's Mars 2020 Perseverance rover launches in a few days' time, bound for the Red Planet, it'll make history as the first mission to carry a helicopter destined to fly in the skies of another world. For its journey to Mars, the tiny 1.8 kilogram robotic drone named Ingenuity is being carried on the 6-wheeled rover's underbelly. Perseverance will launch aboard an Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida on a launch window which will remain open until sometime around August the 15th. It's destined to get to Mars on February the 18th, 2021, landing on a dried-up river delta inside the 45-kilometre-wide Jezero crater just north of the Martian equator. Once on the ground, Perseverance will release its tiny helicopter, which will unfold itself as the rover moves out of its way, undertake a systems check, and then attempt history's first ever powered flight under active navigation on another planet. Ingenuity is very much a technology demonstrator project designed to test new capabilities for the first time, and with only a limited scope. It follows in the footsteps of previous groundbreaking technology demonstrators, including the microwave oven-sized Mars Pathfinder rover Sojourner and the tiny Mars Cube 1 Marco CubeSats, which undertook a flyby of the Red Planet in 2018. Ingenuity features 4 specially designed carbon fibre blades arranged in 2 counter-spinning rotors. The aircraft uses onboard batteries charged by solar cells. The oversized rotor blades will spin at between 2,400 and 3,000 RPM in order to gain lift in the thin Martian air, which has just 1/99th the density of Earth's atmosphere. And it's not just the thinness of the Martian air that's a problem. Nighttime temperatures on the surface of Mars dip down to minus 90 degrees Celsius, and those freezing conditions will push many of Ingenuity's systems to their design limits. So, assuming it survives its journey to Mars, and assuming it safely deploys down onto the Red Planet's surface, Ingenuity will then have to autonomously keep itself warm and autonomously charge its battery from its single solar panel. Only then can the chopper attempt its first historic flight. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, hope to undertake at least 5 test flights during the mission's first 31 Earth days on the Martian surface. And if all that works out successfully, Ingenuity can then begin exploring its surroundings from air, in the process adding a new dimension to Martian exploration. And think about it, this could eventually see similar drones deployed on future robotic and manned missions to Mars, as well as any other worlds we visit that have an atmosphere. This report from NASA TV.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
And that report from NASA TV featured JPL project manager Mimi Ung, JPL Mars helicopter chief pilot Harvard Grip, and JPL Mars helicopter chief engineer Bob Ballaram. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new COVID-19 vaccine being developed at Oxford University is showing promising immune system responses in early-stage clinical trials. The experimental vaccine, called AZD1222, was given to 1,077 UK participants aged 18 to 55 with no history of COVID-19. A report in the Lancet Medical Journal claims the vaccine elicited antibody and T-cell immune responses, with the best results coming from people given 2 doses. The vaccine did cause some minor side effects. but some of these could be reduced by simply taking paracetamol, and there were no serious adverse events. The British government's already signed a deal to secure 100 million doses of the vaccine, while the United States has a contract for 300 million of the initial 1 billion doses being produced. A new study has found that Australia's devastating bushfires last summer caused a likely 14% increase in the number of species now threatened with extinction. A report in the journal Nature Ecology and Evolution warns that the damage caused by the catastrophic 2019-2020 fires could lead to a dramatic jump in the number of native species now at risk. The findings by the University of Queensland show 21 threatened species, including the Kangaroo Island dunnart and the long-footed potteroo, are among 70 animals which have had much of their habitat affected by the fires. Bit of good news now, and Australia's latest National Drug Strategy Household Survey's been released, showing that fewer people are smoking than ever before. The findings show that smoking has declined from 24% in 1991 to just 11% in 2019. And amongst kids, only 0.7% of 14 to 17-year-old girls and 3.1% of boys of that age are now smoking, the lowest rates ever recorded in Australia. However, more concerning is evidence of a quadrupling of e-cigarette use among young adults aged 18 to 24 over the past 6 years, from 5% in 2013 to 20% in 2019. The insidious nature of vaping as nothing more than a new nicotine cancer delivery system is highlighted by the fact that 65% of adolescents and 39% of young adults who report using e-cigarettes for the first time had never previously smoked at all. On the plus side, the study shows that overall alcohol consumption in Australia has also dropped. However, levels of binge drinking remain substantial. In fact, at least once a month, more than a third of people aged 18 to 29 drink at levels which place them at short-term harm during a single drinking session. On a more positive note, the proportion of women who drink alcohol when pregnant has steadily declined in Australia, from 60% in 2007 to 35% in 2019. And most women who did drink would typically have no more than 1 or 2 standard drinks, which amounts to about 1 typical home-poured glass of wine. The figures are important because alcohol changes development in a baby, including the brain, and those changes occur at all stages during pregnancy. The study also shows that while the use of non-medical painkillers and opioids has declined, the use of some illicit drugs has increased. In fact, cocaine and ecstasy use is especially common among people in their 20s and 30s. Also of concern is the continued use of the crystal form of methamphetamine. The study also shows that support for the legalization of cannabis has continued to grow, at 41% in 2019, up from just 35% in 2016, and almost double the 21% level back in 2007. Fewer people thought that the possession of cannabis should be a criminal offence, down from 26% in 2016 to 22% in 2019. And there was also an increase in the recent use of cannabis, from 10.4% in 2016 to 11.6% in 2019. Although over the past 2 decades the trend has steadily been downwards, since the highest reported levels of 17.9% back in 1998. Paleontologists in China have found the fossilised fragments of a new species of non-sauropodian sauropodomorph dinosaur. The fossils, dating back some 195 million years to the early Jurassic, were discovered in Yunnan province. The findings, published in the journal Scientific Reports, show Irisosaurus verminensis was about 5 metres long, with a typical sauropod long neck and tail, but walked on just 2 legs, making it what's termed a non-sauropodian sauropodomorph. The Department of Health is warning people against consuming a dangerous concoction called Miracle Mineral Solution, which its promoters have claimed to be a treatment or cure for COVID-19. Often marketed as water purification drops and sold under a range of different names including Miracle Mineral Supplement and MMS, the product contains high concentrations of sodium chlorate, which is a chemical used as a textile bleaching agent and disinfectant. The Therapeutic Goods Administration warns that a number of people in Victoria have been hospitalised after consuming the dangerous product. Tim Mindham from Australian Skeptics says MMS is made by mixing sodium chlorate solution with an acid such as citrus fruit juice. This mixture produces the toxic chemical bleach chlorine dioxide, which can cause nausea, vomiting, diarrhea and life-threatening low blood pressure through dehydration. Mendham says the main constituent of MMS, sodium chlorite, is a toxic chemical that can cause acute kidney failure if ingested.
For some reason, I don't understand why they're promoting bleach to be used to treat coronavirus or COVID-19. It just strikes me as absolutely stupid. It's a very fundamentalist, very politically oriented church in the US. But this is a local group, and they were selling something called Miracle Mineral Solution, and it contains substances which are just blatantly dangerous. So the federal court and the Therapeutic Goods Administration came down pretty heavily on them and said, no, you can't use it. So they took it off their website. But
how do they justify this?
I don't know, quite frankly. Honestly, it's just one of many ideas that are put forward. It's a quote cure for COVID, right? And it's their idea of a cure, so that gives them some kudos with their followers. It's obviously not mainstream. That's probably also kudos to them as far as they're concerned. They're out there, they're radical, they don't kowtow to anyone, and they just offer up stupidity.
And they mix bleach with fruit juices. Dear idea.
Yeah.
What happens
Unfortunately,
when you consume this sort of stuff, other than kill you? What else?
It is not good for the guts. Okay, I'm not a medical person, but I know that it is highly advised against it.
Life-threatening, low blood pressure.
Burns as it goes down, all that sort of stuff, yeah. It's just totally stupid, and even thinking about it is just crazy. But actually selling a product which contains it is just outrageous. Unfortunately, the TGA is involved in advertising, and that's what its remit is, to stop people advertising certain products. Selling it, well, the federal court has said that you can't supply it. Whereas the TGA can't do that, but you just can't advertise it, especially as it is supposed a therapeutic good, so it comes under the TGA area of activity. But, I mean, advertising is one thing, and then that's the whole trouble. You know, someone can then change the name of the product and change a bit of the formulation. It becomes a different product, and they go back to advertising that.
I'm just dumbfounded by this. This is
it's just trying to push it out to a broader public, and especially a public that's scared of pandemics, and we'll look at any sort of supposed treatment as is happening. There's so many of them out there, unfortunately, and they're unproven, if not dangerous.
If you sell something that is dangerous, can't you go to jail for that? At least one would hope.
I would hope so. I mean, they do get fines. I mean, they have issued fines in the past. There was a company which was selling sort of very, very strange products at some stage, and they got fined $10 million for breaches of rules of advertising, what they could say. The TGA has issued a few fines lately. It's issued one to a gym clothing,
yes.
People who are offering, virus-proof gym clothes.
Yes. Anti-COVID clothes, amazing.
Yeah. Well, they then changed it to antibacterial rather than antivirus. But Pete Evans got a fine. Was it $25,000? So there's various people out there who are getting fines, which is a good thing. But whether that stops them, again, it's actually the fine is about the advertising, not necessarily about the product, and that's the problem.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.